Hello, good morning. Welcome to my talk about decoupling observability. Now, I say my talk, but it's not actually my talk. I don't know if any of you were paying attention to the agenda before, but it was originally meant to be done by our Director of Developer Relations, Peter. Unfortunately, in addition to the many credentials he has, he also managed to pick up influenza. So he's at home in bed, and thanks to Gemini for making a fun picture for me. I'm Kyle. Let's see, what does it say about me? 25 years in managed services, doing monitoring and everything. For fun, I like to do DIY and ride my bicycle long distances. I'm a super randonneur. It's a French thing, so I thought I'd throw it on there because it's cool. So, what are we speaking about today? We'll go back to this. Okay? No, I'll go right to this. Who is Imply? So, Imply, we've been around for 10 years. We're a venture capital based in San Francisco. And we are known as the creators or the creators of Apache Druid, which is a sub-second scalable, resilient, real-time analytics database. That's a lot of words. We've made some money and we have some customers. Okay, so we're going to talk about observability today and how it can be decoupled. Some reports were published in the last year based on interviews with C-level executives. And we can see that we're dealing with skyrocketing costs. So 71% of C-suite leaders say they're actively trying to cut spending. We have too many tools. Many enterprises use more than 10. Several enterprises we surveyed use more than 20 different observability tools in their organization. And this leads to data gaps and silos. And SRE folks like you guys sometimes have to work with multiple tools and might not even have access to all of the data that we're looking for. Having all these different tools, the silos of observability tools are causing some issues. So we start to talk about this idea of decoupling observability, right? And this is what Imply is doing to help with the issues that we saw in the previous slide. So we're going to talk about what makes a good architecture and what are the building blocks that can support that. When we start to talk about architecture principles, these ideas are not abstract. They're more than 25 years old. We use them day in, day out. And this is why analytics has evolved successfully. And again, it hints at why we have things like tool sprawl, data silos, the inability to scale, and problems with concurrency. So coming back to this idea of principles, we can look at this organization called TOGAF, which is an internationally recognized architectural framework that contains architecture principles that guide enterprise architects. So again, not new, 25-year-old ideas. We talk about data as a shared asset. It should be a common enterprise asset, not siloed for different organizations within our broader organization. We want to have ease of use. So these designs should be for humans, not just for computers. Systems should be architected so components can be swapped out, and systems should work across the organization for different vendors. Now, these four things matter because this is how we transformed business intelligence and led to things like data science, helped us move into large language models. And if we've been around long enough, we've lived through this transformation. And the first one that we really talk about, which is really the idea between decoupling things, is Apache Kafka. This is where we really get the idea that data is a shared asset and it should be not tied to a particular schema or a particular UI. It's decoupled, right? Multiple teams can use the same data, looking at events independently. The data has multiple purposes, can be used for analytics, machine learning, alerting, observability. And when we look at what happened with Kafka, we see that when you treat data as a shared asset, we have less silos, we have less duplication, we end up using less tools, and the speed of our decision-making can rise dramatically. Going back a long way, I don't know how many of you have been around long enough to remember when the business intelligence whole environment looked like this, right? We had just a couple database providers, and they had their own visualization tools on top of it. If you wanted to use a different UI or you wanted to use a different language, it was very difficult because the database and the UI were tightly coupled. You had to store data in the right way and then have it. I jumped ahead. Let's go. Okay, so what does it look like today? The modern data stack We have best of breed vendors at every layer, right? So when we talk about where are we storing it from a platform perspective, how are we transforming it with ETL, what database are we loading it into, what visualization are we using, we have best of breed vendors at every layer. Ingestion, transformation, storage, visualization. Parts of these can be independently scalable. Resilience is embedded on all levels. So when we compare this to observability, we start thinking about one, it's a language thing. Are you using PromQL, LogQL, SPL, right? You're locked in at the language level. And two, when we look at the UI and the database, we end up being tightly coupled. We're forced to use the language of the storage system. We're forced to use the user interface that supports that language. So is this changing? Slowly. Splunk, Elastic, Datadog, they've all invested heavily in making their UI easy to use. And they're working on things for natural language, LLMs, using things like MCP. But we still find that the technology requires us to use a particular language. And even companies that are still creating brand new languages. Shout out to Jacek, who talked about this in his KubeCon presentation this year. It's a great summary of where we are and where we might go, right? Where do we want to get to? We want one language that gives us visibility to all our observability data, that's open for everyone, and a protocol that you can build on. I encourage you to check out this talk. I just watched it yesterday. It's great. He's got great ideas and understands where we're going. There's a QR code there, but I'm going to move on. Hopefully you got it. If not, you can talk to me after. Let's think back to how things used to look when we had, for example, Hadoop. We had a tightly coupled environment, and the way that Hadoop survived was because it evolved. Hadoop evolved thanks to hard work from the open source community from a tightly coupled system into a decoupled architecture. So when we think about object storage, where we used to have just HDFS, when it opened up, we have S3, MinIO, Azure, Blob, GCS. We have all these options for object storage. Then for table formats, we now have Parquet, Iceberg, Delta, Hoodie. This whole system opened up from a tightly coupled environment into a decoupled environment and saw huge growth and flexibility. So before decoupling, you had closed stacks, Hadoop or nothing. And it was the same with business intelligence. And now with decoupling, we see great growth. So what are other people saying about this? Charity Major says, observability is about understanding systems from the outside in, not about the tool you use, but about the questions you can ask. So observability is about the questions, not the tool. And meanwhile, the CNCF is all about interoperability and about opening up the stack. So we're moving in the right way. What we learned from business intelligence is that decoupling is necessary. And I believe it's why we have issues now with silos, tool sprawl, scalability, concurrency, performance. We see it with business intelligence. We can see it with observability. We know that the principles work. So let's look at some technology that supports decoupling. So we're going to start with the 3 buckets for the technology to go into, and then look at some suggestions for technology that fits the bill. First box is for all the tools that you have to get data into the pipeline, right? We want to capture and transport data from our production sources, shape it, transform it, wrangle it, clean it, enrich it, all the things that we want when we're collecting data from our agents. Moving on, we start to talk about where the data goes, right? Is it metrics, logs? Is it for data science? We want to persist structured and unstructured data so that we can pose questions and get answers from the data. And then third is how we search it and query it. So we want to define our metrics and logic, explore with SQL or visuals, apply insights to it, use it to train our machine learning models. So from telemetry collection to information management and insight generation, these have equivalents in business intelligence and big data, and we know how these principles have already been applied successfully in our past. Ingestion, storage, and analysis. Same functional families, same principles apply. Collect openly, manage responsibly, share seamlessly. It's a simple model, And we can expand on each box to talk about telemetry collection, insight generation, what goes into what box. So we'll start talking about some tools that we use for this kind of thing. From a telemetry collection perspective, Grafana, New Relic, Splunk, they're all endorsing interoperability using OTel. We're reinforcing that data is everyone's asset. Instrument it once and send it everywhere. That's collect openly in practice. And for SREs, it means fewer agents and less toil. There are others, but basically we're getting towards that Kafka for observability as a result, focusing on things like OpenTelemetry, but we have FluentBit and other things that are working along the way. From the insight generation perspective, we have Grafana and others, which are nice and pluggable. And remember, what we want is you want to choose your UI, not your database. You want to click collect, and then be done. So we're not entirely right there, but we're getting there. So the middle box, what component goes there? Information management. Imply Lumi, why I'm here, is a warehouse for observability data. So it's something interoperable. It just fits. It's something that's about ease of use, making it better for people's everyday work. And it's something that uses data as a shared asset, helping open up more data for longer. So we call Lumi an observability warehouse. It's a powerful engine and storage and compute layer that just fits. It's built ground up from a highly scalable, high concurrency technology. I talked earlier about Apache Druid, so we're building on those foundations of what we already understand, ingesting a lot of data, making it searchable quickly. So it's built from the ground up using highly scalable, high concurrency technology with storage and compute that gives it an edge for observability apps. It offers storage for your telemetry, compute for your insights, and it's all about interoperability. It's a jigsaw piece that works alongside the other tools. Okay. So good news then, these technologies already exist to help us reduce tool sprawl, reduce silos, and do more with our existing tools and apply those good design things that we talked about earlier. How does decoupled information management layer play out? Let's see here. Any Splunk users in the room at all? Anybody using? No? Okay. When we talk about Splunk, to Splunk Web, Imply looks like a remote search head. You just keep using your same SPL. And to the forwarders, it looks like a HEC, like a heavy forwarder, or Splunk to Splunk, or we can do S3 push. There's no new collectors or agents required and no new language. So basically, if you've got Splunk or OTel or anything doing your collection, you can send it to Lumi. You can query it from Splunk, just like you would any other Splunk source. Or if anyone's using Grafana, right, we can load our log data in and we look like a Loki data source, right? If you've got Tableau, we have JDBC. If you're using Claude or some other AI, we have an MCP server, right? So we're opening up that interoperability layer that opens up the stack. It protects existing workflows and easily fits into your existing infrastructure. So you can change your UI, you can change your query tools, collection methods, and keep the same storage in the back end. There's more freedom than single vendor platforms that couple everything together in a silo. So Lumi is meant to coexist. It's about doing more with your data, and it's about doing what we do well, which is compute speed and storage efficiency. So you can see this is our UI, and you can connect to Splunk, your MCP server. We have Grafana, Tableau for JDBC, all different ways of connecting to the same data source. So data in, data out. Lumi optimizes your observability data. It's by this is how it does it, by type independently columnarizing, indexing, and pattern matching to get high compression. These are real DevRel numbers, right? We run these numbers in the lab, and we get this kind of compression by working with modern data structures and compression techniques. And we get 3 times better compression than what you would see if you stored your data in Splunk. So the optimization for storing your telemetry means that you can send WAF, VPC, DNS, CloudTrail logs directly. Lumi stores them cheaply, but keeps them queryable. And now you can investigate data sets that you used to maybe drop after 7 days. You can keep it around for longer because it's inexpensive. From a search time perspective, we compared queries like searches for log data against leading vendor, and we see that we get 3 to 12, 3 to 13 times better performance. It makes every searcher faster, every query. Okay, so the idea is that we optimize everything, protect our workflows, and do more with our data. Almost done. Okay, so here's a couple of blogs that we have up on our website. If you want to understand what is Imply Lumi, if you're using Cribble for any of your Splunk stuff to cut costs and everything, we show how we can work directly with Cribble. And then lastly, as a drop-in layer for Splunk. And yeah, just some docs. Our docs page is pretty cool. It's come a long way since what we used to have with Druid. So when you slot Lumi into your decoupled architecture, you can operate as is, do more with the data you have because it's a purpose-built modern warehouse, allowing you to retain more data and accelerate your searches. So yes, we've used well-proven principles to ready observability data for the future. Come see it in action. We're just at the back table, and I'll be happy to give you a demo if you're interested. So thank you.